Welcome back. Eitan Suez here, Technical Marketing Manager at Solo.io. In this lesson, we discuss HTTP routing rules in a hands-on fashion. So far, we've looked at some interesting use cases, a basic routing scenario. We went then to HTTPS and talked about shared gateways, and but yet the thing that we haven't really explored is the fact that most of our routing rules were fairly basic. It was basically a reference to a backend matching a particular host name. But there are a lot of other options and knobs that we can tweak that are part of the Gateway API, and that is the subject of this lesson. So we'll look at request matching, we'll look at URL rewriting, header modification, traffic splitting in no particular order. And just to orient ourselves to what we're talking about here is when we're writing or drafting routes that are consist of routing rules, we can look at the Gateway API reference section and study the routing rule spec, the definition. And there's a section for matches, which we haven't really explored. There's one for filters. We saw an example with a redirect filter. We looked at backend refs, but we can explore that a little bit more. And then notice that we can configure timeouts and retries. Some of these features are still labeled experimental, as you can see here. And that's what we're going to explore in this particular activity. So we'll start with, I think, an example of traffic splitting, and then we'll look at path and header-based matching, and then we'll move on to filters and some other features of HTTP route. So with that in mind, let's dive into our lab. And we'll begin by looking at backend references. And just as a refresher, we have the HTTP bin application deployed, and we have a route for it. And when we look at the route, we look at the backend references section under rules. You could see it here. And in this situation, you see a single backend ref, a reference to the HTTP bin service. But that doesn't have to be so. We can have more than one. And when we do that, that sort of opens the door to what we call traffic splitting scenarios. And so let's look at an example of that. So when we look at the Bookinfo application, one of the services in Bookinfo is the reviews service, and there are multiple versions of the reviews service. We can define something akin to this. This is a new route that notice that there's a match section there, /reviews. We'll talk about matches more in depth, but this is fairly self-explanatory. We're basically saying that if the gateway receives the request to that particular path, or path prefix rather, then we can route the request to the review service. Now, it's a sort of contrived example, but the idea here is that by exposing a route, and because we have multiple versions of the review service, then we can start playing with traffic splitting scenarios. Let's just go ahead and apply the simple route for starters, and then just test it. And here's an example curl request that calls one of the endpoints on the review service to look up the review for a particular book, maybe with ID 123, and we get back a review. Now, there are multiple instances of the reviews service. You see it there, reviews v1, v2, and v3. And so because there's a single service fronting all three backing workloads, we would automatically get some kind of load balancing between these three versions. Now, what we can do is apply service definitions. Okay, and what I just did here is define a number of subset services, so to speak, right? Reviews v1 service, reviews v2 service, so I can target those backends sort of independently of one another. There's different versions. And that's exactly what we're going to do. So if we look now at a split scenario or a traffic splitting scenario, notice the backend refs section has two backend refs cited, v1 and v2. So we're basically saying send requests only to v1 and v2, not to v3. And then there's a weight field. And the weight field allows us to essentially control the proportion of traffic that's sent to each. And the way this is calculated is oftentimes you'll see people have a convention where they basically use the notion of a percentage, 50-50. But at the end of the day, the way the algorithm works is the weights are summed. So 1 + 1 is 2. And so the first backend has a weight of 1 out of 2, that's 50%. So that's essentially what we're doing here. So if we apply this sort of traffic split scenario, and we can rely on the fact that I think the review service tells us which pod in its response handled the request. We can send 10 requests, and notice that we receive more or less a 50-50 split between V1 and V2, and V3 is not receiving any traffic because our sort of route was very specific about where requests should end up, and it only included V1, V2. So we can do traffic splitting with weights, which is terrific. We can also expand upon that. We'll see an example in the subsequent lesson where we use header matching as a way of deciding which of these two backend refs to perhaps target. All right, so speaking of matching, let's talk about matching. There are different ways of matching a request to basically saying, technically we've already done that with hosts, right? We have a request to bookinfo.example.com go in one direction and HTTP bin go in another direction, but there are other parts of the HTTP request we can sort of latch onto. And so one good example of path-based matching is the existing route that we have against Bookinfo. Notice that we expose, these are endpoints on the product page service, very specific endpoints by using either a path match that's exact or a path prefix type match. There's a third type called a regular expression match, which obviously would be very useful in certain circumstances to pick out specific patterns of URLs that we want to match against. So we can have a list of rules and different conditions upon which different backends would be selected. The API talks about specificity having something to do with the sort of way of working out which rule wins. The most specific one, it does not necessarily have to be the first on the list. If it's more specific, it's going to be the one that matches. All right, so we can do something similar to path matching with header matching. Here is an example, a route for the Bookinfo review service that matches by path, but also by header. And we're saying if there is a header in the incoming request that's exactly matching a key value pair of role equals QA. So if we have a QA tester trying to hit this endpoint, we'll send him to version 3 because that's the new version we're trying to test. But everybody else is sent to reviews v2. So this is a very applicable scenario in many situations where we're sort of preparing to release a new version of a service. And so we can do a header-based matching by simply using the matches : headers. Now the fact that we have both a path and a headers there means that we have an AND condition in play. So let's test this. Let's go ahead and apply this particular routing rule. And now if we send a request, we should either land on v2 or v3 depending on the presence or absence of the header. So when the header is absent, we see reviews v2 is the one that receives the request. When the header is present, we're sending it to version 3. So it's just that simple. All right, on to the next scenario where let's talk about filters, and recall perhaps from a previous lesson that we've already looked at one type of filter when we were doing HTTPS configuration and redirecting of requests from HTTP to HTTPS. We use the request redirect filter. The Gateway API specifies 5 different types of filters. Request header modification and response header modifier are very similar. One applies to obviously the request versus the response. We can do URL rewriting. There's also the ability to do request mirroring. And finally, there's the idea that an implementer can define their own custom filters, and those can be specified using something called an extension ref type filter. So let's look at an example. Where perhaps we want to inject a header in the request before it reaches HTTP bin, for example, and maybe to tell the backend service maybe the provenance of that request. Maybe that service is handling requests both from the outside world, external requests, versus ones that come internally from other services. And so we can look at this little snippet of an HTTP route that essentially uses the request header modifier filter to add a header to the request at the gateway before it's sent upstream to the HTTP bin service, and here I just picked maybe a convention where the request type is the name of the header I chose and the value is external because that request is coming from the outside or through the gateway, so to speak. There's also a response header modifier that works very much the same way, and we can also remove headers and modify existing headers. So there's basically add, update, and delete capabilities. So we can apply this particular route, and then we can send a request to the headers endpoint of HTTP bin. And here we see how useful some of these endpoints are, because they allow us to sort of inspect or to test exactly what we did. And notice here in the response we have a request type external was added to the request on its way to HTTP bin. All right, another example of using a filter for URL rewriting. I'm going to demonstrate this through an example. So for example, HTTP bin has a particular, maybe I'll just copy this before I go ahead and press enter on it so we can see the endpoint that we're targeting. HTTP bin has a series of endpoints that are designed to return different HTTP status codes. So here I'm basically requesting a 304 response. And when I look at the output, indeed we get a status 304 in the response, not modified. Now let's assume that this is an app or an API that we were developing, and one of the common things that happens when we develop APIs is things change over time. APIs evolve, and what used to be available at one path is now available at a different path, and so the URL rewriting capability can be utilized to perhaps patch or support a previous version of a path that no longer exists in the latest version of the particular service. And so we can essentially assume here that, let's look at this particular routing rule. This is a URL rewrite filter that basically says if you encounter requests to the response code path prefix, assume that that's the venerable or the old version of the path that has now become /status. So HTTP bin does not have that particular set of endpoints, but will just rewrite the URL on its way to its target. And so if we just apply this rule, we can verify it by simply sending a request not to the status endpoint but to the response code /304 endpoint, and that gets in a sense redirected, you might say, to the status path prefix. So that's very useful for a number of different use cases. So in addition to this, there are other features which I'm not going to demonstrate. Timeouts and retries that can be very useful from the point of view of resilience. If we want to not wait forever for a response from a service that for some reason has some issue, we can define timeouts in our requests, and that's another sort of field that's exposed on the HTTP routing rule specification part of the HTTP route. All right, so let's go ahead and wrap up. And so some of the main lessons from this exploration are that we can use traffic splitting to support things like canary releases or A/B tests, and we'll be doing a canary release in an upcoming lesson. And we have a variety of filters that we can leverage. I haven't demonstrated them all. There's a couple that were sort of left for you to explore, the request mirroring and the response header modification, but you sort of get the idea of how those work. All right, in the next lesson, we'll look at another facet of Gateway API. How does Gateway API apply to service mesh scenarios? So we'll talk about that in the next lesson, and we'll see you then. Thank you.